Hello everyone, good afternoon. Am I audible? Can you hear me? Okay. Thank you, there. Unfortunately, I have a very bad sore throat today, so I may not be able to speak very loud. And by the way, there was a small complication in there was a complication in the today's lecture because in the timetable it was uh, not set, but then it was reset as we will have a small lecture today. So some of your friends might not know that we have the lecture today. So if you have anyone who's not at the lecture, who may not know the update, please either call them or inform them and say that today we are going to have the lecture. Because I had put a notice earlier saying we had to postpone it, but then things changed and now we are doing today's lecture. So we were discussing about how to create a neural network in the earlier lessons, or to be more precise, about the single neuron and how to train it and all these things we were discussing. Uh, Now, today we are going to complete that section. Right? That day we learn how to do a small like a program or thing like this, where you have a small set of data and how to train the neural network to identify the pass or fail rates. It was a very small program designed to show how uh, the full cycle of the neural network from creating the neural network to training it and testing it and using it. Therefore, it was a very simple one. We did not use the very complicated data set. But today we are going to make a small change. We are going to use the neural networks in real life scenario. So that means we will be using much more, a little bit more complicated examples, data sets, and as well as uh, and some libraries to help you get along with that. So let's get started. Before going there, there are a few things that I want to quickly recap. Now, we have learned how what's a epoch. Epoch is a one cycle where the network goes through one set of sample data. So, for our example, we had used a epoch of 100, which was a fixed number. However, there are other termination criteria as well. For example, uh, one termination criteria is you set a particular level of what do you call accuracy, and once your accuracy is reached, you can stop training the network because you have achieved your goal. Or you might have a network where the accuracy is not increasing any further. So the improvement between 100 epoch and the 1000 epoch is negligible. Then that means it doesn't matter how many times you are spending, the accuracy will not increase. Then you can stop. Or when it comes to the fixed number, you have set a maximum number of iterations, and when you reach that, again you can stop. So those are the three termination criteria of a neural network. Yeah. Uh, the next thing I want to discuss is about what will happen when you have multiple weights. So earlier we had our example set to single weight, one input, one weight. So the adjustment criteria was also very easy, right? You can see the adjustment criteria is basically neural network error times input times weight into neta. But when you have multiple inputs, your error will be the same because output of the neuron will be the same. But when you're calculating the weight, you have to calculate for separate weights. So let me show it using an example. If you have only a single neuron, things are easy. You have only one input, let's say x1, and one weight, and based on this, you calculate some kind of error. You have the output, and based on this, you calculate an error. And from this error, you calculate how much weight you are going to change, delta W. Now, this depends on the particular input and the error and the amount of weight itself. Those three factors will come into play. Right? For example, if you look at the equation, you can see in this equation, you have this error, input, and the weight. Now, what will happen if you have multiple inputs? Then the same calculation need to be carried out for each of the inputs. So, I1, I2, and I3. You have W1, 2, and W3. You read the signal, then you do the transfer, and you get the output. Since you have only one output, that means the error will be the same. Only one error for a single neuron. But if you want to calculate W1, delta W1, you have to use this input and this weight and this error in the calculation. If you are going to calculate how much you need to change the W2, you have to use this as the input, this as the initial weight, and this as the error. That's how you are going to calculate delta W for this weight. So it's similar to this one. Only difference is, rather than having it calculated once, for each weight you have to do the calculation. So in generic, you can say it's something like this. Something like this. So you can see only difference is now when you're calculating the weight change, you have several weights. And for each of these weights, you have to calculate separate delta W's. 4 inputs means 4 weights, so 4 delta W's. How do you calculate separate delta W? You get the error, multiply by the respective input and multiply by the respective weight and the theta. And this I is the new term. So this is how you calculate when you have multiple weights. Same formula. Only thing is, instead of running it once, now you have to run it for each weight every time. Each weight every time. The next thing is, there's a special weight that is commonly used called bias. This is for mathematical reasons. So when you say actually one input, in reality, neural network will have the neuron will have two inputs. One coming from your data set and one fixed value. So this one is a fixed value. It doesn't connect to any of your input data. It's just a fixed constant, usually +1. However, it also has a weight attached to it. We call it as W0. So this is the bias. So this one has one input coming from the data and another bias coming into it. So when you say you have two inputs in your data set, you have two inputs like this, but you also have a bias coming into the neuron for the calculation, right? So those are some of the background information that we need. And today we are going to cover two main topics. One is about multilayer neurons. Other one is about how we can practically use neural networks and as an example. So now let's talk about multiple layer neural networks. The one we have been talking so far are very simple problems, right? If you have a classification problem, and if you can separate them using a straight line, like this, straight line or a plane, this is called a linearly separable problem. You can simply draw a line, and this side have one category, this will be the other category. These are called linearly separable problems. Single layer neural networks are able to solve linearly separable problems. But sometimes you have a complicated problems. You can see this one and this one belong to the same category, but these two belong to another category. You can't draw a single line and separate them. You need at least two straight lines or maybe a curve to separate them. So if you want to solve such problems that are not linearly separable, you need to have at least two layers. So that is where the multiple layers comes in. When the problems become complicated, you can't separate the classes using a straight line. Then you need to have multiple layers. So this is a linearly separable one. You can solve it using a single neuron. This is not such a question. You need to have at least two layers to solve this. With the introduction of the multiple layers, we understand there's another problem appearing. Let's say you have a three-layer network like this. The feed-forward network. So you have these things connected. And let's make some input. These are the inputs. Let's say you have two inputs. Now let's look at how the data flows. You give some values here, and the value goes in like this. And you have the weights and everything. It calculates the value here. And output of this neuron goes in like this into this neuron, and output of this neuron goes here, and output comes like this. So you can see data is flowing from this side to this side, from the input layer towards the output layer. This is why it's called feed-forward network. You are feeding the data forward. But how does it work when it comes to calculating the errors? So let's say you have an error here. I mean, how do you know what kind of error you have in this particular neuron? But we don't know, because only possible place where we can compare the value is at the output. Because at the output, we have the neural network output and the actual output. Actual output we know because we take it from the data set. That means at this point, I can calculate the error. Because I have the output from the neuron and the actual value. So I can calculate the error here. So once I calculate the error in here, I can back calculate the error that is coming from this neuron. I am back calculating it. And once I know the error in here, I can calculate the error at this point. Like this. my array calculation goes in the opposite direction. My array calculation starts at the output layer and I calculate backward towards the input layer. Hence, this is called backpropagation. Right? So when you have multiple layered feed-forward network, you have an error calculated in backward. We call it backpropagation error calculation algorithm. I do not need you to remember this equation, but here's an example. We start from here and we use a little bit of calculus to calculate the error at the previous layer. So this is how the errors are calculated. You can see the bias as well here. You can see the bias weights are here. You're calculating it in the reverse direction. Depending on the number of layers, you can classify neural networks into two main categories, either shallow or deep neural networks. Shallow networks usually have about 3 layers, while deep neural networks can go up to hundreds of layers. That's the first main topic I wanted you to talk to you. So with that, we come to the conclusion of the theory part of this one. By the way, there are other transfer functions. So you can just Google it and find what other transfer functions are out there. Some of the most common ones are log sigmoid, tan sigmoid, pure linear, hard limit, and we have another one called rectified linear unit, ReLU. Now, ReLU is mainly for the deep neural networks, right? So those are some theory parts for this one. Now let's start writing some codes with practical use. Do you have any questions so far? Any questions? Okay, if you don't have any questions, we will go for some coding, and meanwhile, I will post the Google form so you can put the attendance there. So please fill the Google form for attendance. Right. Now we shall start by starting Google Colab as usual. And now we are going to use a separate library to create a neural network and to train it. Reason is, so far we have been doing everything from scratch, right? We wrote our own weight algorithms, updates, and everything. This is okay to understand the concept. In fact, it is good. So you know what's happening inside. But in the real world applications, the problems will be more complicated. You will have a lot of data. So efficiency, speed, and accuracy and everything is important. So writing a program again from scratch is not that easy. On the other hand, there are many other libraries available that can help you with this scenario. You don't have to write everything. You can use an existing library to get the necessary work done. So that's what we are going to do. We are going to use a library called TensorFlow, which was developed by Google, a very famous library, to run several neural network programs. And also we will be using some data sets available in the internet. So you don't have to type it, right? You can just import it and do it. TensorFlow is Can be used for other functions as well in machine learning, but it's mostly famous for the deep neural networks. So we'll first start by importing the TensorFlow. Let's make a small shorter form called TF. And by default, the TensorFlow should be installed in the Google Colab, but if you're not sure, you can check it using this one. Print TF double underscore version double underscore. Now remember, this is actually two underscores, not one, right? So I want you to type this in your chat. No, sorry, I want you to type this in your program and see whether you are getting any version number or if you are getting any errors. If everything is okay, you should get a version number here about the current TensorFlow version. කාටත් මේ මෙතන errors කවුරු හරි ආව නම් කියන්න නැත්නම් run කරලා බලන්න මේ TensorFlow version එකක් install වෙලා තියෙන්න ඕනේ. This is double underscore, not a single underscore, two underscores. ඉවරද? ඒක type කළාද? Good. Any errors? No, right? Now the first problem we are going to solve is a very small, a very simple one. That is about flower classification. There's a very famous flower classification problem called iris dataset. And so in this dataset, scientists had measured different properties of three different species of flower. We have iris setosa, iris versicolor, and iris virginica. So what they have done is they have measured the length and width of the petal and the sepal and recorded in a table. Our object is to see whether we can identify the flower type based on the size, based on those numbers, right? We have to identify what's the flower type based on the length and width of these flowers. Now, let me tell you where we can find these kind of data. So UCI Learning Repository is one of the famous ones where you can find a lot of data available free of charge. You can see there are many data of different types. But one thing you have to be careful is this data is provided by volunteers around the world. So they don't have the same format. Some will give the data in Excel, others might give it in a text format. Some will have the data in CSV format. Some might be images. Some have different naming conventions. So before you use it, you need to open the dataset and check what kind of format they are using, right? Anyway, it's a very good one. You can see there are so many data available. So now I'm going to check for the iris dataset. You can do a Google search called iris UCI, and you should be able to get a page like this. Here in the page, it gives you some information. It says there are 150 instances. That means there are 150 samples. They had measured the size of 150 flowers. And each sample has 4 attributes. Length and width of the sepal, length and width of the petal. That's why it has 4 attributes. Do we have any missing values? No. Some dataset might have missing values. Sometimes they can't measure certain attributes in certain samples. Then they put as missing values. Here we don't have any missing values. So where is the actual data? To get the data, you can go to data folder, and here you have a file called iris.data. First, let's open it and see what it looks like. So click on it, and you will see the flower dataset downloaded. And this is what the dataset look like. You can see several values, and they are separated by commas. So this is actually CSV file, comma separated value file. So the first four attributes, first four numbers are attributes. Last one is a text explaining the flower type. So we have set of data from iris setosa, another set from iris versicolor, and finally we have another set from iris virginica. Right. So now I want to import this data into the Python work environment. So let's go ahead and do it. I am going to copy the link address, and I'm going to create a new variable path and paste the data. I don't need this one anymore, so I'm going to just remove this one. So this is the path to my data file. Just to make it easy, I will paste it into the chat as well. Okay, you can use it. So this is the place where you have all the data. Now we need to import it. So we have to divert a little bit from our main topic at the moment. Because when we are working with this kind of data set, it's easy if we have a library that can manipulate this data. Otherwise, we have to do everything line by line manually. But there are some good libraries that allows you to quickly manipulate data, take a preview, delete some columns, rename, and all these things, right? So I'm going to import one such library so I can easily import the data and work with the data. So the library I'm going to import as SPD. This has nothing to do with neural networks. This is just, I'm using it just to manipulate the data. This is a large data set, so it's easy if we can have a library like this. So I add this one and run it. Now I have another library called pandas. In the pandas library, you can very easily import a CSV. So this is how we import the CSV. So it has import data. This is just a variable name, ed read CSV. And we give the path. Right? So this should import the data from this path and set it to this particular data frame. And then we are looking at the data frame. So when you run it, we should see some preview. See, we can see some data is here. When you finish up to this point, please give me a signal, either raise your hand in the chat or do something. We can continue the rest of the code. Okay, good. If you want, you can have a preview using this icon as well. So this will convert into a little bit easier to work with kind of scenario. However, when you look at this data, you will realize there's a small problem. So this is the sample number 0, 1, 2, 3 like this. This should be the column header, right? You know, in the Excel, when you create a table, the first row is the column header, the title. So by default, the CSV thinks this import, when you import it, it takes the first row as the titles or the headers. But in our original data set, we did not have any titles. This is actually the first sample. This is not a column header, this is the first sample. Right? So we have to make sure this is become the sample, not a header, not a title. And because of the same reason, I have only 149. But in reality, you should have 150. So I'm going to tell it that in this CSV, I don't have any headers. That way, it will take the first sample, first value as the first sample. Now I have 150. That's there. But now I have another issue. By default, it had put the column headers as 0, 1, 2, 3, 4. That's not that meaningful, right? So let's rename them. Rename some titles into these lines. So the way we do it is, say, imported data. Columns. Then you can give the title names. I'm just going to copy paste it from here. And now when you run it, you should have a better understanding. So PW stands for petal width, petal length, sepal length, and sepal width. And the type. Type is the flower type. So do this and let me know. Now you should have 150. And when you complete it, let me know. Kapila, Ashan, Mahesh, did you finish? Are you still working? Udara, Virada, Udara, Virada, Tamkarnada. Okay, you have that. Okay. Anita, Anuranga, Are there any way to paste URL on the code? Yes, you just right click and say paste. Okay, now I think everyone has done this one. So let's look at this data set. Let's say I want to see 100. You can see there are a lot of samples. We have all these numbers. There are actually 3 different flower types, right? 3 different flower types. But for the first example, I want to only use the first 2 flower types. That means I only want samples from 0 to 99. Third flower type we will add a little bit later, right? So I'm going to select part of this data frame. So let's call it a simplified data. Later on, we will add a third type, but for the time being, I just want to use only 2 flower types. So I'm going to say simplified data. And how can I select them? Imported data. There's a function called head. Head means from the beginning. If I say head 99, that means select 99 rows from the beginning. If I view this one, you will realize now I have only we need 100. We have 100 rows. So the first 50 is iris setosa and last 50 is iris versicolor. Right? So we have simplified. That means we have got only first 2 flower types. Since this is the first example. Now, can I use this data directly as it is on a neural network? Or is there anything I want to change? Can I use this data directly on the data? Is it possible to use this data directly on training a neural network? What do you think? Why not? You may remember neural networks only accept numbers, right? This is just a column index, so that doesn't matter. It's just a way of understanding the sample. Pulse, PW is number, PL, SL, SW, all of them are numbers. But we have a problem here. It says type. Type is given as a text. Type is given as a text. So that's a problem. We need to convert this type into a number. We need to do an encoding. Right? Okay, the assistant had posted a question. Yeah, that's now this error should be very obvious. It says length mismatch expected 5. So you don't have 5. You have 5 columns, but in the column title you have typed only 4. So it doesn't know how to fit 4 titles into 5 columns. So that's why it's saying that. Right. So coming back to the main topic, we need to encode it. We need to replace this with a number. So we can follow the same process as we did earlier. Earlier we put pass as 1 and fail as 0. So we will do the same thing. But rather than doing it manually, we'll ask the Python to do a find and replace. Right? So this is what we are going to do. So my final data I would like to put in this particular variable. It's the encoded data. And I am going to do find and replace. Simplified data replace. Now, if I want to replace multiple items, you can do it in a single go. So it goes like this: to replace. What do I want to replace? Now I want to replace iris setosa with the values of 0 and I want to replace iris versicolor with a value of 1. So this line basically do a find and replace. So my flower type now becomes as a number. See, now the type is no longer displayed as a iris set or versicolor. Instead, it displayed as a number 0 and 1. I did a simple find and replace. But remember, this is a text search. So you have to put it within double quotations. But this is a number, not a text. So you don't put any quotes around these 0 and 1. Right? Okay, let me know when you finish this one. You are the Mahesh, what about you? Finished? So at the end, you have prepared your data set. So up to this point, there's nothing related to neural network. I'm just importing the data and make some minor corrections and changes. It's more suitable for training a neural network. Now let's start splitting this data into categories. Why do we need to split the data? Reason is, first you need to split them as inputs and outputs. As you have learned earlier, in a neural network, you feed some of the data and you expect some value from the other side. So you have an input for the network and the output from the network. So in this case, what will be the input? What is our expected output? Can you name the columns? What columns will be the inputs for our neural network? Now in this neural network, what are we going to predict? What is the expected output? Kapila, what do you think? What is the expected output? We are going to give some data and asking it to predict something. So we are going to give it this height, weight, weight and length and everything, and ask it to predict the type, what type of flower this is. So our input will be these four attributes, and our output will be the type. So when you give these numbers, neural network will try to predict the flower type. So that's the objective. So these will be the inputs, this will be the output. That's one way you can split. Other ways, you need to split it to training and testing datasets. You will be using set of data to adjust the weights. That is the training. Then, once it is trained, you need to have a separate dataset to test the accuracy. So usually you have about 80% training, 20% testing, or 75 to 25, that kind of ratio. It's not good to use the same data to train and test. It will be like you are giving some questions in the classroom to practice, and for the final exam also you are giving the same set of questions. Then you can't actually measure the how well the student have learned, because they might have just remembered all the answers and just split it back without understanding the concept, right? So in the exam you should give something similar but different, not identical, same type of question but with different numbers. Same with neural network. If you want to measure the performance correctly, you have to give it a different set of data, not the one used to train. So that's the one we are going to do first. We are going to split into training and testing data. Now, you might see we have 100 rows. So if we select first 80 as training and last 20 as testing, do you think it's a good idea? First 80 for training and last 20 for testing. Is it a good idea? If not, what is the reason? උත්තරයක් දෙන්න බලන්න. Okay, okay, good, good. Some people have figured it out. Now this data set is a sorted data list. It's already in a particular order. So last 20 will always belong to one particular flower type, right? So that's not a good way to test. If this is a random data set where everything is jumbled together, maybe last 20 will be good. But the way it is given now, it's already sorted. So the last 20 will always have a flower type 1. So that's not a good way. So we better take samples from random places. For the training and testing, we will randomly select data. Fortunately, there's a built-in function that allows you to do this very easily. So I'm going to say train data. And here I can give the percentage, the fraction of sample data I want to have. Now when you run it, you will realize we have 80 rows and they are randomly selected. You can see the 40th, 50th, 52, 99 like that. The sample is drawn at random locations, right? So this is the training data set. It's selected from the original data set. 80 rows randomly selected from the original data set. Now I want to have the testing data set as well. Now how should the testing data should be selected? We have the original data set. From it, we have selected 80 for the training. So remaining 20 should be the testing. From the 100, 80 for the training, remaining 20 should be the testing. So how can I get the remaining 20? What we can do is we can get the original data set, and from it we can remove that 80. Drop means remove. We can remove that 80, already selected 80. So what is left will be the remaining 20. So how can I remove the 80? I can say this. So you have the original data. From it you select 80. And each row can be identified by this index. Then you have the original data, and from the original data you remove these indexes, rows with this particular index. So what is remaining is the test data. So let's look at a preview of this one. Okay, we can see we have 20 test data and it's randomly selected. You can see both zeros and ones mixed together. Right. Now we have split them as training and test data. Now we are going to split them as inputs and output. So this is the train input. So which row, which columns, or which attribute should come for the input? So which columns should be selected as the inputs? You have a set of data like this, and from this you can select different columns. Which columns? If you are giving it as an input, very good. We can, from the train data, I'm not going to use all the columns. I'm going to use selected set of columns. What are they? This. I am going to select these four as the input. And similarly, I can have train target or train output. So for this one, what should I come here? What should be put in here? For my target or the output? What is my output? Yes, we need to have the type. So if you look at the train input, you will see something like this. This will be the input for the neural network. You have 80 samples. Each sample has 4 attributes. Now, while we are at it, let's do the same for the testing. So the testing also, we need the inputs and outputs separate. So I'm just going to test it. Next, we are going to build a neural network. So that's the first place we are going to use the TensorFlow. So before going up to that point, I want to make sure everyone is okay up to this point. If any of you are having any issues or errors, please let me know. Right? Because if you have any errors, then training will be a problem. If you don't have any errors, please put it in the chat so I can get an idea how many of you have completed, how many of us are still writing. Right? I'll give you about 2 minutes to complete if there are any issues. Right? Quickly complete this and let me know when you finish. There's a question in the chat. Why we use check test output and train output in code line? We could use the same code. Yes, you can use the same code block, no problem. These are not hard coded rules. I just thought okay to be better. You can test it in the same block, no issue. Right. So I guess everyone is up to this point. Now we are going to create our first neural network. As everything, our neural network model has to have a name. Let's call it a artificial neural network. And then you have to give the network type. Now, TensorFlow is the core behind this program. However, there's an API that can be used to make it easy to easy to work with. We have an API called Keras that allows you to write the code easily. So we will be using that to write the code. So we will go like TensorFlow Keras. That's the API. Then you need to give the type of the neural network you are going to build. Now, if you are building a feed-forward network, type should be sequential. Sequential means it's based on layers, different layers. The model I'm going to build is a feed-forward type of neural network. Then I need to add layers into this one. Right? I need to add different layers to this one. What you can do is you can say my ANN dot add, and then you have to say TensorFlow layers tens. Why is it not popping up? should give a pop-up. They don't give a pop-up. Ah, right, right. This capital simple issue. That's the problem. Right, now it should work. Dense and so this one basically adds a new layer, and here's the layer we are going to add. Dense means a Filipino layer, and then you can give the number of neurons. Let's say 3 neurons. This layer has 3 neurons. Right? And if you want, you can have activation function. The activation, you know. So activation function means the transfer function. You have learned about hard limit, softmax, soft logic, sorry, hard limit, tan sigmoid. Like that, you can have different activation functions. So this one I'm going to use a rectify linear unit. And I am going to share how much weights I need to have. For the first layer, I need to specify, it's better to specify the number of inputs. So this is optional. If you didn't specify it this time, it will later calculate it based on your sample data. But I thought it's better to give it. So this allows the layer to know that there are 4 inputs coming from the inputs. You need to know that each neuron has 4 weights. You can see there are 4 inputs, right? So that's what the input shape means. So this is only required for the first layer. Right? Now I have add one layer. So let's add another layer. This layer we can have 4 neurons, and we don't need this one. And let me add the last layer. And the last layer, I need only 1 neuron because I am only getting one output. Okay. So this is how you build the neural network. You have the network type. This is the first layer, second layer, and third layer. Each layer has its own number of neurons like this, and activation function. And if it's the first layer, you can give the size of the inputs as well. They don't have to be the same type. You can change the activation functions if you need. Change them. So this is when you run it, you should get something like this. Then we need to add a compiler. Compiler means we don't still specify what kind of training algorithm we are going to use. Right? So here I'm going to define what kind of training algorithm, what kind of all those things are. I'm going to define using compile method. Compile. Then you can give how you are going to calculate the error. For example, if your output is a number, let's say rainfall, are you going to calculate the root mean square error, or just the mean square error, or the average error, or the absolute error? Like that, there are different ways you can calculate the error. So here we can define it using the loss function. How you are going to calculate the error. Now, when you have categorical data, we usually use something called cross entropy. Cross entropy means how many samples are correctly classified, how many samples are incorrectly classified. Right? And if you have only 2 classes, like in this case, we have only 2 categories, we can use binary cross entropy. So if you have 2 classes to categorize, you can use binary cross entropy. If you have more than 2 classes, I'll tell you later. you have cross-categorical, you have another cross-entropy category. Right. I'm going to add another optional variable here. Now, when you're training the neural network, you need to follow through different number of epochs. Right? It's going through different number of epochs. So for each epoch, I like to know the performance of the neural network. Is my performance increasing? Or are there any problems? Is it going to saturate? So like that, if you want to know how the network trains with each epoch, you can have an output. That's called a matrix. So there you can ask for different parameters. How is the accuracy? How is the speed? And things like that. So I'm going to say accuracy. So each epoch, it's going to print the accuracy of the neural network at that epoch. So now we have compiled the network. I'm going to train it. Train is done by keyword called fit. Fit. Then you have to go to the training input, followed by the train target. And if you want, you can have a number of epochs as well. Say 100. Or target train output. Right. Now when you run it, you should see fit got an unexpected keyword epoch. Okay, spelling mistake. Epoch. Now if you have done properly, you should be able to get something like this. It will actually grow number of epochs up to 100. And for each one, you will see a loss function, accuracy, and things like that. Right? So run this program and let me know if you have any errors. Here you have learned how to create a neural network, how to add layers, and what are the parameters in these layers, and how to compile it, and how to train it. So once we have trained it, we can test the accuracy of the neural network as well. So for this, we have another built-in function that can help you. We can use evaluate followed by the test input and test target. Test target. it will give you an idea about the accuracy, and it's like this. And let's say you are satisfied with your program, you want to use it in the real world. Then what you can do is you can use predict function. Predict function will take some input and give a prediction. Okay. Example, let's put some numbers. Okay. So this one falls into category 0. If I make some changes, let me take it from some other sample. Let's try this one. Okay, this one seems to be a little bit overfitting, so I'm going to change the network structure a little bit. You can see the accuracy is around 0.5. So let's make a little bit of change. I'm going to change it to and this into software. See if that make any changes. Mhm. At the moment, the accuracy is not that good. So later on, I will tell you how you can increase the accuracy. There are some optimizations you can run for this one. No, maybe we'll do it at the moment. We have the problem here, now we have to solve it. But if you disregard the accuracy issue and the performance accuracy issue. The steps are as I mentioned earlier. You have to get the data, format into a correct format, and then you can use these things to create a neural network. Try to see. I removed one layer just to see whether it will increase the accuracy. Didn't happen much. Then I changed the activation function into softmax. Again, not very good. Same level of accuracy. And I added another flag here. What it basically does is it stopped printing all that data here. Otherwise, you might see every time I run this program, I get 100 lines of performance. Now, I don't want to print all that, so I just stop it using this verbose zero mode. So the training actually happens, but it doesn't display the result. I can just run this one and evaluate the performance. So I'm going to do a little bit of optimization. So I'm going to say we are going to use optimizer called Adam. That should help me increase the accuracy. Right now it's about 0.5. It's still 0.5. Maybe we can do a batch train then. We can do is we can do a batch train. Batch size. We'll see whether that's going to. So it should be not here. It should be in the train. Still 0.5. What's that? Okay, that's a question. Why 321? Why we get three networks? We don't have three networks. We have only one network. Name of the network is my ANN. We have three layers. Since it's a feed-forward network, we have three layers. So this is the first layer. That layer has 5 neurons. This is the second layer that has 2 neurons, and this is the third layer. It has only 1 neuron. Okay, it's a single neural network with three layers. Okay, this one still going 0.5. Little bit better, 0.6, but that's not good enough. Anyway, so those are the steps that is relevant if you are going to train a neural network using the tensor library. So now I am going to improve it a little bit further to include the third category as well. Right? You might remember we had reused only 100 data because I did not want to make it a little bit more complicated. Now I'm going to include all the three categories. So this will have some several differences when it comes to make changes. So I'm going to create a new notebook for this one. By the way, when it comes to like this, rather than just predicting a number, it's better if you can give the category. So now we know the output should be something like between 0 and 1. We can say anything below 0 is setosa and anything above uh, 0.5 is versicolor or something like that, because we know that's the midpoint. Right? That's the midpoint between 0 and 5. So we can do something like this. You can give the flower details. It will make the prediction. So those are the main steps. And this is how we create a neural network and train it. Now we are going to add the third category into this one as well. So I'm going to write it in a new notebook. But most of the code will be the same. So I'm going to import the TensorFlow as we have learned. And I am going to import the data as well. When you run it, and by the way, if you have a very large program, you can actually enable the GPU or TPU to make it run faster. Now we have 150 rows. Earlier, we selected only parts of it, right? If you remember, we selected only 100. But now I want to select all the 150. But with this comes a little problem. If you have more than two categories, you have to use something called one-hot encoding. Otherwise, it will be hard for neural network to predict. What does this mean? Let's say you are trying to predict a vehicle type, right? Based on the size and weight and everything, you are trying to predict a vehicle type. Let's say there are three different vehicles, bicycle, motorbike, and the car. Then if you try to put them like this, 0, 1, 2 as the flower, the vehicle type, it's not good. It's not going to work well. Instead, for each type, you need to have separate column. In your sample, you have separate column for each type, right? So you have the weight, height, and color and everything. And then you have three columns. One column saying car, one column saying bike, another one saying bicycle. So if it's a bike, you put a 1 for the bike and car a 0 and the motorbike 0. So like that, this is called one-hot encoding. So for each category, you need to have separate column. And if a sample belongs to a particular category, you have to put a 1 to that category. And if a sample doesn't belong to that category, you have to put a 0 for that category. Right? So that is how we are going to do it. Fortunately, there is a easier way to do it than manually. We have a library in the pandas library. You already have that particular function. So let's try to implement that. So the way we do it is, let's create another data frame. This is called one-hot encoding. And in the pandas library, we have something called get dummies. And there we can give this one, let's say imported data. And in the imported data, we have type. This is the one that we want to do one-hot encoding, right? These are numbers. This is the category, the classification. So we are going to say one-hot data type. And when it creates new data type, you like to add the word type into that as well. In a moment, you will realize what I'm saying. Let's run this one and see. So in the original one, you can see I have a single column with different attributes, different classification categories. Retro, subversive, allergic, like that. Here, they are replaced by three different columns. So if it's iris setosa, you have one for this one and others are zero. One for zero. Here you have zero, zero, and one. This type is actually for this particular word, okay? This line says which column I need to do the one hot encoding. This line says whether I need to append something to the beginning. Now you can see how it changed. Rather than having a single column, now you have three columns. But the same data represented in a different manner. Now we need to add these two because this table has all the petal length, petal width, and all the numbers. And this one has the type. But actually, this should be the same. So let's join it. So what I can do is I can join it using, let's have another name, encoded data. You can have imported data, joined with one hot encoding data. So now we look at encoded data. You get a table like this. Earlier we did not have these three columns, but now we have these three columns. It's the same data but represented in a different way. Converting these kind of categories into this type of numerical representation is called the one-hot encoding. This is called one-hot because for each row, you have only one true value. Okay? You have only one true value. Yeah? There's only one last thing to do before we come to the original. We can use it for the data. Now, if you look at this particular type column, we don't need it anymore, right? The same data can be recovered from these three columns. So we no longer need this one. We can remove this particular column. This column we can remove. So let's remove this one. Okay, I asked you to drop the type column, so I ended up with something like this. So I want you to try this at the moment and let me know if there are any questions. So axis 1 means you are going to remove the column. Axis basically define whether it's a row or a column or a layer. This in place means I want to update the data frame itself. Whatever the variable, I want to do it itself. Otherwise, what's going to happen is if you don't use the in place, the original data will be not changed. Instead, you will create a copy of the changed data. So without this one, you won't see the difference in the type one. Then what you can do is you can do the same thing if you do something like this. for the same result. So either you can create a copy and update the original one, or you can just do it same in place. So when you finish, let me know. Okay, now we have the encoded data. Next step is to split them into sample and training and testing data. Just going to copy paste it. But there are some changes you need to do. Can you identify which lines need to be changed if you are going to use it with our new example? Which lines do we need to change? Can you identify which lines to be changed? For example, do we need to change this line? Do we need to change this particular line? Yes, no, maybe. Now we have a set of data and we want to split into training and testing. These two lines, are they okay to do this particular task or do we need to change it? People who say this is okay, raise your hand. Okay, these two lines are okay. And if you look at the input, yeah, this is also okay. But what about this one? This line needs to be changed. What is my output? Can someone put it in the chat what's the output should be in this case? For example, when you run this is what it looks like. So what should be my output? How many outputs do I have and what are they? Not 150. That's the number of samples. Output in the sense attributes, properties. Earlier we had something like this, right? This is our neural network. We have parallel width, parallel length, parallel length, parallel width. We pass these four values into this one, and we got a now. This could be a 0 or 1. In this case, what's the difference? You can see there are 4 inputs and 1 output. Now, how many outputs do I have? Based on the table, if you look at the table, now all these things, some of them will be inputs, some of them will be outputs. So what are the inputs? What are the outputs? What attributes or what properties are considered as inputs? And what properties or what values or what characters are considered as outputs? Earlier we had only one data type, only one. That is the type. But now we have 3 outputs from the neuron. We have 3 outputs from the neural network, right? So our neural network, lastly, will have 3 neurons. That's one change. And the other thing is number of outputs will now change. Rather than having a type, now we have this. Okay. And let's train the neural network as well. We can just copy it. So it's going to be a sequential one. 5 to 1, okay. This one we have to change. Now we have 3 neurons at the last layer. This point you have to change. 3 neurons at the last layer. And also, this is no longer a binary loss entropy, so the loss function has to be categorical. Categorical cost entropy. That should be okay. Your neural network should train. What we can check the accuracy as well. Let's increase the number of neurons a little bit. Now I had increased the number of epochs into a little bit larger number, and then look, the accuracy reached 1. That might have been the case in our earlier situation as well. So here we first had it, when we tried to do it, our accuracy was not that good, right? We had around 0.6. Maybe if we can increase the number of epochs, it might have been able to do a better prediction. This is my previous example. I'm just checking whether it will increase the accuracy. And I'm also going to give you 2 tips. One is that it takes a little bit longer to do this, right? So when I increase the number of epochs, the time taken to train it is larger. It's high. Because at the moment I am using a CPU. But you can make a much faster result if you change the runtime environment. So what you can do is you can go to runtime, change runtime, and use hardware accelerate like TPU. So when you change the runtime, you have to run it from the beginning. So that's one way you can increase the speed. You can change the runtime environment to enable hardware acceleration, like a TPU or a CPU. Another way you can increase the speed is by putting some known values for the initial weights. When the neural networks are initiated, it need to have some values for the weights. What we usually did was we randomly set some numbers. But it's better to have some average values for these weights. So it already have a little bit of performance at the beginning. Right? So if you want to do that, now this is a optimization technique, right? So it's not a must. But if you want to do that, You can have something called kernel initializer. So when you're initializing your kernel, it's already have this weights assigned into. Then you can evaluate. You can see accuracy is pretty good. And if I want to test a value, I can do something like this. I can have a set of values, ask it to make a prediction, and based on the prediction, you can select the category. My neural network has a different name. It's called my ANA. You can see when I'm asking for the prediction, it gives me three values. Because my neural network has three outputs. So the first output is almost 1. Other two are almost 0. So this is 10 to the power minus 2 and this is 10 to the power minus 11. So if you remember how the categories are made, when you look at this, if the first category is 1 and others are 0, it's almost like a iris setosa, right? So that represents iris setosa category. So by looking at this, I can say, okay, this must be a iris setosa because it has 0.98 while others are almost 0, right? So this is how you can use a neural network to predict multiple categorical classes. Any questions you want to ask? Okay, if you don't have any questions, I will wind up for today. And I think next day we have the exam. Not the next day, I mean, we don't have any lectures in between. So if you have any questions, this would be a time to ask.